All right, so this is the second module on OpenFlow. In this module, we talk about only controllers and the OpenFlow tools. 3 items: controllers, and then some software routing platforms. This is nothing to do with the OpenFlow, but it's important to know about them if you are going to do anything in networking. Talk about them and then OpenFlow related tools. So open source routing software has nothing to do basically with OpenFlow. But I put these slides because anytime you do anything with OpenFlow or SDN or any of these things, you will run into these pieces of software. And so if you go to Wikipedia, it has a bigger list. And I didn't put the big list here because really these 3 that are the one that I ran into myself when going through the OpenFlow and SDN and so on and so forth. So different SDN tools, different OpenFlow tools, they use these 3 pieces. And I put them in the order in which I believe they are being used. Quagga is very famous, very popular. And this is basically a piece of software you can download from somewhere. And then you have a router on your PC if you have enough output input ports. All right. If you have a VM, you can download it onto the VM and then you have a virtual router there. Okay. And so this is very widely used for many things, and now it is used for real things as well because everything is becoming a VM, everything is becoming a software. And so these pieces, which were first just, for people to experiment with and play with, now they're being used in production. Right? The next one is Bird. Bird Internet Routing Daemon. And this came from some European university. Anyway, it has many things, and now it is slowly replacing Quagga. Okay, it is used in several internet exchanges as a route server, and it has replaced Quagga because of its scalability issues, because Quagga has some scalability issues. Now, this claim is from Bird by themselves. Okay, so I cannot independently verify that this is really happening. But Quagga is very famous, as I said. I read about Quagga everywhere, and then I read about Bird, and it says that it is replacing it. So I put that first. And the third one is ZARP. ZARP is designed by Berkeley, and but it has been replaced by Quagga. So, that is the third one. So between the Bird and Quagga, I know somebody is first, and then ZARP is there, and then there's a whole list in Wikipedia. So now, if you want to know about OpenFlow, then there are many other software that you will run into, and I just decided to talk about 4 here because the list is longer than like 60, 70. I myself personally prepared the slides on about 20 or 30, and then I gave up. Okay, so I'm not going to go to 20 or 30. I'm just going to show you where to find them if you need them. But these 4 are important, so I'm going to talk about them. First is FlowWizer. So FlowWizer fits directly below the controllers. You could have many controllers running, and there could be different controllers. Technically, I say, let me put it theoretically at least. You could have different controllers, although I would have difficulty really verifying that. But anyway, so let's say you have many different tenants, and each of them have a controller. They can talk to the FlowWizer, and the FlowWizer will talk to the switch, to the switches. And by doing this, what FlowWizer is doing is making this whole thing multi-tenant. So the controllers don't have to worry about virtualizing. Each controller controls whatever pieces it controls and has complete control over that. And then these could be divided. So half of this switch, for example, could belong to one controller, other half to other controller. And what the FlowWizer does is the switch thinks it is talking directly to the controller. So it sends to that. And then the FlowWizer intercepts it, looks at it, what it is, where it is going, and then it gives it to the right controller. So in that sense, it provides the slicing. It slices the network into pieces which are controlled by each controller. And so because every packet is inspected, it does cause slight latency, but other than that, basically, so, that is the goal of FlowWiser. It is developed by Stanford ON Lab. I think they call it ON or ONRC Lab, or Open Networking Research Center, ONRC Lab. MiniNet you have already used, so you know, but I put this slide here just for the completeness. So it is widely used emulation environment. Again, it has nothing to do with the OpenFlow, but it has implemented OpenFlow as well. So MiniNet is for emulation of networks. And it can simulate end host switches, routers, links on Linux. And it is very widely used for prototyping of the software-defined networks. So in SDN work, this is very widely used. Even I have heard that it is used in production. Production means that in a company, if you have a network, you have a real network and you have MiniNet simulation of it. All right. If you want to change anything in the real network, first you simulate it in the MiniNet. If it goes okay, then you put it into the real network. So it's that good. So it has a built-in Open vSwitch and it has OpenFlow capable switch separately. Wow. And then you have used the command line, MN, topology, tree, and so on and so forth. So I don't have to tell you. And you can use diagnosis. You can use perf, iperf, ping, and other things. And not only that, there is a MiniNet code for several popular commercial switches. So you could buy a Cisco switch and a MiniNet code for it. And that's how you put your production environment in the MiniNet. Is that it is not just a general switch, it's a real Cisco switch in there. So this is very useful piece. Third thing is RYU. So this one is developed by NTT. And what it does is it has all the OpenFlow stuff just like other controllers. But on the top of that, it integrates with OpenStack to support OpenFlow. Now, what is OpenStack? Everybody knows what is OpenStack, right, by now? Right? So OpenStack is the cloud management system, and that is used in the real clouds, such as Rackspace and other people, they use OpenStack. And so in those clouds, you can use RYU to manage OpenFlow switches. So provide software component with well-defined APIs for network management and control applications. And it supports all those things, and then can easily set up a multi-node OpenStack environment using pre-configured RYU VM image file. And that is one of the things that is true for most of the things that we talked about, including Quagga or, or MiniNet or everything that we have talked about so far, is that everything nowadays comes as VM appliance. So you download this file and then you just run it on one of the hypervisors, whatever it is suited for, and you have the thing going, right? So is RYU. RYU is runs on a appliance image file. So the route flow is an extension which allows you to do routing. Now, OpenFlow generally, is layer 2 stuff, right? But if you want to do routing over that infrastructure, you can use route flow. What route flow does is that it takes your virtual topology and you say, well, I want to have one router here, one router there. So you have those routers which are VM by themselves. And they are connected by whatever method you want them to connect. These are actually all virtual connections. And so they generate, and generally you will be running Quagga on them, right? Because they are routers. And so they will run OSPF or BGP or whatever, and then they put that all that stuff, they give it to the route server and route flow server. Route flow server then programs the OpenFlow switches to implement that forwarding. So here it is from layer 3 come down to layer 2. All right, layer 3 is virtual, which runs on a physical layer 2 right here. And so this virtual topology, we call them route flow clients. They give their thing to the server, and the server centrally implements them on all the switches. Little bit more detail is that this one shows that you have a VM here. This VM is a router, this VM is not. And there is a vSwitch, right? Since this VM is a router, it has this routing protocol, Quagga or whatever, so it has a kernel space and it has a user space, right? In the user space, you have the route engine, which takes some information from the kernel space and then produces the information which is sent to the route flow server, which has a database. Route flow server also has a GUI for human beings to control whatever policies they want. Anyway, this database is fed to the controller, and which may consist of the proxy, may consist of the applications, may consist of the statistics and topology discovery. So basically, the topology discovery is going this way, and the flow starts are going this way. So these, you see the arrows directions, these are unidirectional arrows. So these go into the database, and then from the database, the information comes for the route flow proxy, which basically program the switches. And there are references for each of these things, more details. Then there is a whole list actually. As I said, first I had about 10-15 slides like this with 4 or 5 each, and then I gave up on them and just put one. So this list has 5 of them, and for some reason I felt that these were more important than the other 45. So let's see. So AVR is used for the floodlight network administration and testing. Now floodlight is the controller from Big Switch Network. So that's really a commercial controller in some sense, right? And this actually, it turns out, must be there from Big Switch Network, which basically puts the graphical user interface, for administration testing. So this is similar to SNAC snack that we saw for the OpenFlow controller, for Knox, etc. Now OFLOP is basically a benchmark which measures the OpenFlow operations per second for a controller, or a switch, actually, for a switch. So if you have a switch and you want to see whether it is a fast switch or not switch, you measure it in terms of how many OpenFlow operations it can do, right? So this is a benchmark. cbench is the thing that you use to do benchmark. So it's the benchmarker which measures the performance of the controller by generating packet in events, new flows from the bench of for new flows from a bunch of switches. So this one measures the controller. So basically what happens is the switches will say, oh, I got a new flow, please tell me what to do with it. That is called packet in event. So it sends that packet in to the controller and the controller responds back, right? And so this one generates the packet, the switches generate the packet in event, they go to the controller and we measure the controller, figure out how fast the controller is. Twister is test automation to manage and drive test cases written in any scripting language, which is suppose TCL, Python, and Perl. So you could write whatever you want to do as a script and then run it on Twister. Fort Knox is an extension of Knox which automatically checks new flow rules to check if it violates the security policies. Now it has been succeeded by SE Floodlight. So this was for Knox, Fort Knox, but now Knox is not used, by the way. You know that Knox has gone to POX. So this is for Floodlight. SE Floodlight is for the Floodlight. Okay. And that brings us to the end of this. So summary is 5 key points as usual. First of all, you might just want to remember these controllers: Knox, POX, Beacon, Floodlight, Trema, and SNAC, which is the graphical interface for Knox. Out of these, right now, POX and Floodlight actually are probably remaining, but they are also going to go away soon. But anyway, they are remaining. Trema is from one of the Japanese companies, so that is again might be used in some kind of production environments. In terms of software routers, we have Quagga, Bird, and Zarp. Quagga is very famous. FlowVisor is used for multi-tenancy and multiple controllers. In terms of tools, we saw Mininet, RouteFlow, and RYU just a minute ago. So you remember Mininet is for emulation, RouteFlow is for routing, and RYU is for what? Anybody remembers? Nobody remembers Open something? Yeah, it's for OpenStack. Other tools, and there are then testing, security, benchmarking tools, and there is a whole list of 100 tools somewhere, and I will give you the URL for that in a minute. Let me repeat the question, and actually it's better explained by the next slide. The question is, what do these routers represent compared to the switches? The switches belong to the cloud provider. Who do these routers belong to? Is that a question? Yeah. Okay. So the whole physical infrastructure does belong to the cloud provider, and each tenant has its own part of it. It doesn't really matter here because we are just looking at one tenant. Okay. So let's say physically it might belong, this switch might belong to Amazon, but I have rented it, so right now it belongs to me, right? And I want to run in this, and actually this switch is a part of a processor inside which I have 3 VMs, and I want to run router on one of them, and I want to use the other one as something connected to the router or whatever that is, right? So all of this virtual stuff belongs to the tenant for sure. The physical stuff technically belongs to the tenant for the time duration and belongs to the cloud provider otherwise. And the new thing is that these routers can come and disappear and come back again at the whim of the tenant.
So the cloud provider uses RouteFlow to be able to configure both of their customers, the routers as well as switches, so that they can have virtualized
in L3 environment, yeah.